BIOS and the UEFI. When you hear the word firmware, you think of a type of software that is used to control a device. That's partially right. Firmware is actually software that is encoded into a read only ROM chip. This software can run on its own without the assistance of an underlying operating system. In fact, systems that do not have a formal operating system are controlled by a system firmware of some sort. BIOS and UEFI is really the firmware underlying the operating system of a system. This software runs before the operating system starts. Now, let's look at both of these individually. Then we'll look at them in parallel and how they compare with one another. Starting with BIOS. BIOS, or the traditional legacy BIOS, the basic input output system. The BIOS is the computer's firmware. Some other specialty cards on your mother's board will have its own firmware utility, such as the RAID controller card, um, the graphics cards. Some of these, again, have their own utilities to configure those peripherals. Now, BIOS is one of the most important microchips on the motherboard. The BIOS contains the BIOS system, which boots your computer and allows your operating system to interact with certain hardware. Also, BIOS contains important settings that instruct how your hardware will interact with the operating system. So, in fact, BIOS is what actually starts your system. There is also a part of BIOS called the post. We'll talk about this a little bit further. Post is the power on self test that basically tests all the hardware devices as your computer boots. Now, the BIOS resides again on a chip on your motherboard. You can check your motherboard's manufacturer, the manual, to see the exact location for your BIOS chips on that board. BIOS has been around for over 25 years. Older systems talk through the BIOS to the hardware systems. Now, as BIOS, again, has been around that long, technology advanced. And as technology advanced, BIOS start giving us limited support for today's technology. Now, also some other drawbacks to BIOS is the BIOS settings, of course, had to be saved, and they're saved to what's called a CMOS battery, complementary metal oxide semiconductor, or CMOS battery. The CMOS battery had to have a power source to store the settings. That was a big disadvantage. And here you can see screens of the BIOS format and the BIOS layout. A very basic graphic system to interact with the hardware devices and basic operations. There was configurations for setting the day and the time, booting of the hard drives and what order they would boot, and things along those lines. Now, compared to the new UEFI BIOS, UEFI is a lot more advanced. The Unified Extensible Firmware Interface is the advanced replacement for BIOS. The UEFI allows even more support for systems and platforms. It allows for new features that would not be possible under the legacy BIOS firmware. Now, some of the advantages of the UEFI firmware. The UEFI firmware can boot drives of 2.2 terabytes or larger. In fact, the theoretical limit is 9.4 zettabytes. It supports secure boot, which means that the operating system can be checked for validity to ensure that there's no malware has tampered with the boot process. UEFI also has a pre-boot environment with its own shell and drivers that can browse the internet and has remote diagnostics, even without the OS. Changes to the UEFI are saved to flash memory and does not have to involve the CMOS battery. So those are some of the advantages that we get with the UEFI. And with those advantages, we would need those because of the newer technology that's coming out. Now, the CMOS battery we talked about before, it is the battery that's used with standard BIOS. BIOS settings were saved to the CMOS battery so that a constant source had to be powered, kept to that power source in order to save the configuration. Um, if the CMOS battery lost its power, all the settings were lost. If the BIOS had a password settings for security, simply removing that CMOS battery would clear that setting and put it back. So in newer systems with the UEFI, the only thing that the CMOS battery does is just keeps track of the date and time. Now, we talked about post earlier, and post is a very important process to both the BIOS and the UEFI. Post is the power on self test. So when a system powers on, the CPU performs a check on the hardware. The motherboard polls all the devices to check for issues. If an error is detected, it will display it on the screen. Now, post works before the video card is enabled. So the first thing you would see if that video card was not the faulting piece would be a error code of some sort. If trouble were detected and the video card was not active and it was detected before the video card, you would hear a series of beep codes. And those beep codes vary by the manufacturer of the board. Again, these series of beep codes could indicate that there was a problem with any one of the components. And you would count out the beep code, look at the corresponding information, and see what that error device is. Now, the BIOS setup utility. When you get into the BIOS setup utility to make changes to your computer, um, it keeps track of the hardware changes in your system. It keeps track of the number of hard drives, the boot order, changes with the system, also the enabling and disabling of key hardware like USB permissions. You would set your USB permissions and the capabilities of a USB. Virtualization, you turn virtualization on, and also CPU features. Now, again, the BIOS is the heart of your system and it must be protected. Assessing the BIOS is a very straightforward process. And again, this would change depending on the manufacturer of your computer. During the boot process, you have a small window of time to access the BIOS by either pressing the delete key, the escape, or F2. Again, depending on your system's configuration, check with your manufacturer because that key sequence could be different. Once you're in the BIOS or the UEFI, you have different options for booting. You can change the boot order of your computer, change what your computer is going to boot from, whether it's the hard drive or a USB device. You can also change boot locations. The first device is normally the first the device it will boot off of, but you can change that order. UEFI works the same as the older BIOS. And again, for your specific motherboard, you want to check your manufacturer. Also, things you can do in the BIOS or the UEFI is considerations. With the BIOS and the UEFI, you can monitor key information of your system. You can check for voltage, bus speeds, fan speeds, temperature. Some utilities allow settings to be changed, like you can lower and higher the fan speeds. You can set threshold warnings of the temperature in your system. If a temperature gets so low or so high, it'll sound out a warning. Common speed settings for your fans would be standard, turbo, silent, and manual. Secure boot, we mentioned this before. This feature is found only in the UEFI. Prevents unwanted software from booting the computer. Digitally secure signature of a known good software, and it's cryptographically secure, meaning it's using cryptographic keys to make sure that that operating system has not been tampered and the it's nothing like malware or anything else booting that computer. Hardware encryption. Hardware encryption is something else that you would have in your systems. You can encrypt the entire hard drive by using full disk encryption. Now, this is an operating system, but there's also systems to encrypt and protect your system in the BIOS or UEFI. The Trusted Platform Module, or the TPM, this is a specialized chip that stores RSA encryption keys, and it's used for host system authentication. Now, the TPM can either be built into the motherboard or added to the TPM slot, as you'll see on the image here. And it performs encryption and decryption of your device. Also, there's hardware security modules. Now, hardware security modules are physical devices that add an extra layer of security to your computer. Now, it provides physical access protection, secure key management. It could also be used for file encryption or even a secure boot. Now, the hardware security modules come in a variety of different devices. It can be an add-on card, a USB device. It could be a server across the network or in the cloud. The hardware security module is it will connect and contact your computer to provide authentication before that computer boots or a file encryption. So it's a hardware based or separate type of authentication or security layer. Security CPU architecture. There are different types of CPU architecture, and we're going to talk about two types here. That is the common instruction set computing, or the CISC, or the reduced instruction set computer, which is RISC. Now, these two CPU architectures are very important. Um, of course, a CPU's main job is to compute data, and the way the CPU performs this function depends on the type of architecture it has. The CISC and the RISC are instruction set architectures, or ISAs. Basically, it's the set of commands that a processor can execute. They both do the same task, but they do it quite differently. The CISC instructions are complex, and it takes multiple mathematic tasks with one instruction, and each instruction can take several clock cycles to complete. An example of this would be if a CPU was rated at 3.0 gigahertz, it can do 3.0 billion cycles in a second. Now, the CISC was the original ISA and the most well-known technology. And the CISC actually is the x64, x86 platform that's been popularized by AMD and Intel. Now, the RISC architecture is known by the most popular processor in use today, the Advanced RISC Machine, or the ARM. That uses the RISC architecture, the ARM processors. The ARM is the competing technology to Intel and AMD. So let's look at some of the characteristics of both. For the CISC, or the Intel and AMD processors, it emphasizes on hardware and includes multi-clock complex instructions, small code sizes, high cycles per second, and uses less memory. Whereas RISC, it focuses on the emphasis on the software. Single clock, reduced instructions only, large code sizes, low cycles per second, and uses more memory. Uh, the CISC process or architecture, the Intel and AMD, it's best known for the Intel and AMD desktop servers and laptops, whereas the ARM architecture using the RISC is used in the Apple A15 processor, the Samsung Exynos, smartphones, and wearable devices. Single core and multi core. Now, our older processors, they were just a single core processor. They did one set of instructions at a time. As technology advanced, as things get faster, we came up to multi core processors. So, multi core processors process within one processor, but each core acts as its own processor. So, you have multiple cores and they're individual, independent processors. Now, the operating system must support multi core technology. Now, the number of cores is dependent on the processor type. Multi threading is another technology. The string of instructions that a CPU runs is called a thread. Older processors were only capable of running one thread at a time. New CPUs can now perform multiple threads at a time. This is called multi threading. Now, the Intel market, their multi-threading technology as the hyper-threading technology, or HTT. Intel's HTT is a form of simultaneous multi-threading SMT, which uses a newer CPU. This technology can have multiple instructions operating on separate data in parallel. HTT shows itself in the Windows 10 Task Manager graphs as twice as many CPUs as the system has cores. So if you see, say for instance, in our example here in the image, it has 10 cores, but it also has logical of 20 processors. That's that multi-threading working. Another function that you'll find on the motherboards or in the BIOS or UEFI is virtualization support. You turn on virtualization support either in the BIOS or the UEFI. It's a very simple process. Computer virtualization is actually a CPU or CPU feature. The motherboard centralizes location to make the changes right there from the motherboard. Now, some motherboards do not support virtualization, some CPUs. It's simple to enable, and your manufacturer settings would vary. It's basically just an enabling that feature. Okay, in this lesson, we dove in down into the basic input output system, or BIOS, in the Unified Extensible Firmware Interface, or UEFI. We talked about the boot options, the USB permissions, the trusted platform, or the TPM security features, fan considerations, secure boot, the boot password. We talked about encryption and also CPU architecture. Thanks you for joining me with this lesson, and I will see you in the next lesson.